Here we have a SAT math problem. Okay, let's go to the question. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object was launched. According to the model, the object was launched from a height of 8 feet and reached its maximum height of 1800 feet 16 seconds after it was launched. Based on the model, what was the height in feet of the object 24 seconds after it was launched? Okay, let me consider an XY plane. Okay, we have y-axis, now we have x-axis, and we can take the time in seconds on x-axis and height on y-axis in feet. According to the information, the object was launched from a height of 8 feet. So let's take this number 8 on y-axis over here. So the object was launched from this position, that is from a height of 8 feet, and the object keeps going up. It has reached a maximum height of 1800 feet. Then we'll have value 1800 on y-axis corresponding to this maximum height. And the object has reached the maximum height of 1800 feet 16 seconds after it was launched. Corresponding to this maximum height 1800 feet, the time on the horizontal axis has to be 16 seconds. Then we'll have 16 over here. And after reaching the maximum height, the object keeps coming down. So here we have a parabola with the vertex 16, 1800. Now we can write a quadratic function which represents this parabola. Since we know the vertex of the parabola, we can write the quadratic function in vertex form. That is y equals to a times x negative h whole square positive k. And we know that h comma k is the vertex. For h comma k, we have 16, 1800. We have y equals to a times x negative. For h, we can plug in this value 16 whole square positive. For k, we can plug in 1800. Now I got the quadratic function which represents the parabola we have over here. But still, this quadratic function is not complete because it contains an unknown constant a. To get the value of this constant a, we need a point on the parabola. We can consider this point, that is a y-intercept 0, 8. Let's plug in this point 0, 8 into this equation. We have to plug in this x coordinate 0 for x and the y coordinate 8 for y. Then we have 8 equals to a times 0, negative 16 the whole square positive 1800. Let me subtract 1800 from both sides of this equation. Then this positive value, negative value will cancel out. When I simplify the stuff on the left side, I'm getting negative 1792 equals to a times this 0, negative 16 can be written as a negative 16. That is negative 16 the whole square. Okay, negative 1792 equals to the evaluation of negative 16 the whole square is 256. That is we have 256 times a. Let me divide both sides of this equation by 256. Then this one will cancel out. When I divide this value by 256, I'm getting 7. That is negative 7. Here I got the value of a, that is negative 7. We can plug in this negative 7 for a over here. Then the quadratic function will become y equals to negative 7 times x negative 16 the whole square positive 1800. Now the quadratic function which represents the parabola over here is complete. Our aim is to get the height of the object in feet 24 seconds after it was launched. We know that x represents a time in seconds and y represents a height in feet. So we have to plug in this 24 for x over here and find the value of y. So that is the height after 24 seconds it was launched. Okay, now let me plug in 24 for x over here. Then we get 24 negative 16 the whole square positive 1800. Y equals to negative 7 times 24 negative 16 is 8. That is 8 square positive 1800. Then we have y equals to negative 7 times the value of 8 square is 64 positive 1800. Y equals to, when I multiply negative 7 and 64, I am getting negative 448 positive 1800. Y equals to, when I combine these two numbers, I am getting 1352. That is 1352 feet. Okay, 24 seconds after launch, the object was at a height of 1352 feet.